Hello, and welcome back to the MOOC Circular Economy for a Sustainable Built Environment. When we talk about the built environment, we mostly do not envision one massive entity, but rather the compilation of smaller elements and different scales, from material to building to neighborhood and regions. All those scales need resources to be constructed and function throughout the life cycle. Circularity is seen as a way for better managing those resources. Therefore, the built environment offers various opportunities for reducing its impact. In this video, we will discuss the central role that building products have in developing a circular built environment. Products have to be designed in a new, smarter way, with longer lifespan and possibilities to be repaired, upgraded, and even adapted in other systems. Moreover, circular products should take into account their influence on the other scales of the built environment. To understand how and when to intervene, first step is to look at the life cycle of the product and their environmental and economic impact. In this lecture, I will focus on the life cycle phases of building products from production to end of service. Those life cycle phases are similar in different products. Let's take the brick, for example. Brick is one of the most commonly used products in buildings. Its history dates back to ancient times. Since then, the size, shape, and composition of bricks has changed, as well as their making process. Let's have a closer look at the life cycle of a clay brick. First comes the production phase. It includes extraction of raw material, transportation, and manufacturing. So, the very first stage in the brick production is the raw material extraction. Clay bricks consist mostly of clay minerals, mixed with water, potentially also using additives and coatings to enhance the properties of the final product. After extraction, raw materials are being transported to the production facilities. Clay can be found locally or brought from further away for quality or financial reasons. The clay's origin location determines then the environmental impact of the transportation activities. The next stage is manufacturing. Brick manufacturing includes making of the clay mixture, forming or extruding the bricks, drying, firing in a kiln, and finally packaging. In this production phase, the highest environmental impact occurs during firing and the emissions of burning fossil fuels to fire the oven. The packaging process also has a contribution to the overall environmental impact because of the material and machinery used. After production, the next phase in brick's life cycle is the construction or application phase. After manufacturing and packaging, bricks are being transported to the building site, where they are installed on the building, or rather form the building itself. Brick's most common function in the construction is the construction of external or internal walls. They are laid in different arrays using connecting mortars. The way they are used in the building construction also determines the type and the construction method. For example, facing bricks that are placed as an exterior layer have been manufactured to tolerate water. They are denser and have been fired in higher temperature. Hollow bricks, on the other hand, have better insulating properties, but they are not used as the final surface. They are often plastered or being used at the inside layer of the facing bricks. After the construction is finished, the bricks are in place and ready to fulfill their function during the use phase. This phase is the most extended part of the life cycle in terms of time. Clay bricks can be used for 80 or 100 years or even longer. The lifespan depends on weather conditions and construction techniques. During their use phase, bricks don't have direct negative environmental impact since they require very little maintenance, such as, for example, repointing to repair the connection. Finally, as being part of a building component, the wall, for example, bricks reach the end of the service life when the building is demolished. At this stage, the brick construction is disassembled from the wall in loose components, together with the rest of the product and material composing the building. The demolition has an environmental impact as it once again involves diesel-powered machinery and results in waste. Bricks, as part of demolition waste, are transported and often disposed in a landfill as a way to manage the waste. Thus, the negative environmental impact at this stage can be associated with the demolition and the transportation. Bricks resting in the landfill are harmless. But is this a sustainable and circular way to handle construction waste? Let's talk about a few solutions which can help to close the loops, meaning that the brick, as part or as a whole, can continue or restart its life cycle. One option to close the loop is recycling. The bricks can be used as a secondary raw material after being shredded and employed in various construction activities. For example, they are used for road beds. In this way, however, the brick is downcycled. Attempts are made to keep the value of the product and upscale them into new building products, such as bricks or tiles. Unfortunately, recycling is at present energy inefficient and lacks proper infrastructure, which makes it less economically feasible. The best option then would be reuse. Brick walls can be dismantled, and after the mortar is removed, the bricks can be reused. However, dismantling a brick wall may be dangerous, and removing the mortar difficult and time-consuming. To avoid that, products can already be designed to be easily disassembled and reused. A good example of such a design are the dry stack bricks. The mortar used to join the bricks is replaced by plastic units, which makes the bricks easy to separate and reuse. This approach decreases the environmental impact of the bricks because it extends the life cycle and reduces the need for new products. To make this possible, the end-of-use scenario was already considered when the bricks were designed and manufactured to fit the system. So, in this video we discuss the life cycle stages of the brick from production to end of use. Although the life cycle stages are similar for different products, the duration of each stage, particularly as far as the use is concerned, can differ. Thus, different products have different lifespan, meaning lasting for longer or shorter time. Recognizing the importance of the different life cycle stages and their environmental impact will help us to close the loops and move towards a circular built environment. We can, for example, intervene at the end of service scenario by reusing or recycling, as in the case of the brick. To make this happen, we need to be proactive and think in advance how to extend the life cycle of the product or recover and reuse the material. Or we can decide to reuse existing components to remanufacture our new building products. Those decisions are made even before production, during the product design. How the building products are designed determines how they can be used to close the loops. Can you think of the life cycle stages of different building products, such as windows, doors, internal partition, lamps, kitchen, cupboards, tiles? How would you intervene to make them more circular? Think about it.